Okay, so I would like to present an interesting case. It's about the difference between the label GPS and GPS DD in terms of the dump to JSON. If you look at label GPS.cpp, look at the dump to JSON. I have two different ways to handle this. So this is option number one. So option number one, I make a copy of the parent and then I call the parents dump to JSON. And then I have option number two. Essentially, I directly force the call to the GPS DD, so it will directly call the parent version of the dump to JSON. Okay, so I'm going to write the program, which is the wrong option, and let's see what will happen. Okay, this is a wrong option. The following is a wrong option. So what I will do is I'm doing this. Let me see what I did. This is interesting. I'm still doing this, but over here, I'm doing casting. I'm going to cast GPS underscore DD star. Okay, so if I cast this, so if you look at this, I'm casting this to be a GPS DD, because what is this? This is a label underscore GPS object. Now a pointer to a label GPS object. So I'm casted to the parent, or alternatively, I can do this as well. So this is all equivalent. I can do this as well. I can dereference and then use the dot operation. By the way, these two are equivalent. All right, these two are the equivalent. So I'm doing casting by pointer, and I'm not okay. I have another way to write this code. By the way, I can do this. I can do this as well. Star. I think this three option, they should give me the same result. So one is casting the pointer, one is dereference the original pointer, then casting with the reference to GPS DD, and the other way is do like this. So let me, the one that I'm not so sure it will work is the second option. So let me try to get the 1 and 3rd casting, and then so I want to see if the compiler will love this idea. Wow, it works. Okay, so I'm going to run the program. So I'm expecting the program will just crash because okay, you see that the program have a segmentation fault because just keep accessing itself. So let's try to look at the other option. And the reason it will crash is because dump to JSON is a virtual function. If it's a virtual function, when you do this, it will still go to the vtable and try to find dump to JSON. So it will call itself. So it's just keeping calling itself and never finish. So eventually running out of the memory space, and then it will have a segmentation fault, those kind of runtime errors. So let's use the first option. It should give me the same thing. Yeah, it's still segmentation fault. Let me try the third option. Wait a minute. I thought I already, wait a minute, I forgot to, 1 second. What did I do? Yeah, okay. The first option also let me use the third option. Yeah, again, I have a segmentation fault. So let me try to do another thing. If I modify, get rid of all this, and then I use this option. This is option number 2. Now I have no problem, okay, to go through this. And let me try the other, finally, there was totally 5 options, 3 won't work, and 2 will work. Let me try the option number 1, our original one. And here, there's 2 line. Yeah, it works as well. Okay, so this is our the different way. We just go back to the code so you know what's the issue. The issue is the option 1, I just basically make a copy. So over here, I already have another object creation time. And the V table right now for the parent copy is pointing to, I should basically do this. The V table pointer, 1 second. The V table pointer will link to the class GPS ED because this is because of the creation time. Object created. Okay, over here. And over here, I'm using a different mechanism. I kind of force the compiler to link to the parent version of GPSDD. Sorry, parent version of dump2JSON. So you can do this because even if this function is defined as a virtual function everywhere, but you can still using the class name colon to enforce the code to actually call that version. Okay. So for by the way, just between those 2 options, I think option 2 is probably the better one because they avoid copy. It's just directly forced to call that if you know what you're doing. So I'm going to keep the option 2 as the default. Okay. Any question? Johnson or okay, I'm going to pause here. Okay, so let's try to see if we make an example a little bit more complicated. So I'm going to copy label gps.h to Google Map GPS. Okay, I create another class minus NW Google. Okay, and then I change this to okay, over here, let me get rid of this part. So over here, I'm defining this as, okay, label GPS. So inherit from label GPS over here is Google Map GPS. And then I say, okay, virtual public, I will keep it that way and label GPS. Okay, so Okay. Sorry, I make a mistake. This should be Google Map, GPS, and then public to label GPS. Okay. And over here, I do not need to have the label because I don't need that. But I could have, wait a minute. Hold on, let me do this. I could do this. STD string. I would say URL. Do you know what URL is? Universal Research Record is like your HTTP link is URL. Okay. Let me get rid of this. And then over here, of course, I have to change this to Google Map, GPS. And this is Google Map, GPS. By the way, if you do the memory layout, that's related to homework 4. We will talk about that, why I define all this memory layout stuff. It's just try to make things to work. So operator equal is Google Map, GPS. And over here, this is going to be Google Map, GPS. Dump to JSON should be the same. Okay, if I defined it this way, by the way, you can think about this is that even I thought something is labeled GPS, it could be some or one of the subclass. So the inheritance hierarchy in a typical system, it will be multiple layer. It's not just 2 layer. Now we're kind of extended. So that's why the compiler really don't know. Okay, the compiler really don't know the exact type that you have at the object creation time, but it will generate code such that at runtime, when your program asks you the code, it will retrieve those values. That's kind of the PowerPoint I present. Yeah, that's the role between the compiler and runtime. So compiler essentially generate code. So at runtime, you will be able to handle this kind of polymorphism concept. Okay, any other question? David, Jonathan, or Baran, right? Yeah,
I like the concept is like I like understand the idea of virtual functions, but if I had to want to write code for my own inheritance system, I would not. It would be a huge struggle because in theory, I understand it, but in practice, I feel like if I tried to put code on paper, it wouldn't go very well.
Okay, that's I think that's true. I think that's true. Okay, so now homework 4 will get you to exercise some of the virtual function. Yeah, tomorrow. So this is my experience. I try to respond to your question, Jonathan. What's the difference between understand somebody else's code about virtual function versus how to develop a virtual function yourself to apply to some practical scenario? So it's usually there are 2 conditions for us to consider to have why we want to use a virtual function in the first place. The first condition is that there are situations in your application such that I need to collapsing the inheritance hierarchy to one of the parent. So essentially, I'm changing all the object, the type, casting up to that particular object. So in other words, I need to do that for some reason, but I also lost the original type of each of the object. Okay, that's a condition number one. So the condition number two is that, okay, when I really have a function that I really need to execute at the original level. Okay, I lost the type, so now if both this condition are true, then I will use a virtual function, right? That's why we want to use virtual function. So therefore, if we need to develop a virtual function program, we first need to identify in the design what is the hierarchy, under what situation I need to collapsing, move up everybody to that level. What is that position? And then the second question you should ask is what function I want to, the second condition, right, to execute. Okay, so once you know this, you already know what is the function signature that need to be defined in pretty much every single class in the whole tree. Oh, by the way, it doesn't have to be all of them, because for example, for some of the branches, I actually realized my parents' version of that function works perfectly fine. Then I don't need to define an actual virtual function. That's a detail, but the default is that you have a virtual function everywhere.
So it's like, so it'll be like one top class and a bunch of like things coming
Right.
off of it, and then each one has its own function if it needs it.
Right,
Because
exactly.
it'll be like slightly different.
Right,
Okay.
right. You can see that the difference between the dumped JSON from GPSDD to label GPS, right? You know you need somewhat different. And then if I inheriting again to Google Maps GPS, I'm going to include URL, right?
Yeah.
So URL, I might need to handle things differently as well.
Okay.
Okay, by the way, if when I have URL, this is going to be homework 5 or homework 6, that I can use the web programming. I can call the library to be able to really retrieve the data from the URL as well. It's become really interesting in that sense. Yeah.
Okay.
Does that to be honest with you, it's a pretty challenging concept, virtual function or polymorphism. But before you can use properly, always look at those two conditions.
Yeah.
So let me write it down on the conditions because it's recorded, is important for other students also learned about this part as well. Okay, I'm going to, you can still see my screen, right? Okay. I'm going to put it under virtual function. Two condition to apply the concept of virtual function to our program. So condition number one, we need to upcast a whole bunch of object to their base or ancestor.
You're saying upcast is just moving upwards, right?
Right, move up to the base or base, because it could have a multiple level of depths.
So would that be if we have like a function in base class that we want to run and the function in the bottom class that we want to run? Like you have in labeled GPS, like you have the first dump to JSON that we use? And then
No, when I say upcast a bunch of object to the base, I basically only talk about, let me write it down here. I want to convert a label, convert all the label GPS object to GPS DD object. And also, I'm convert all the Google map GPS objects also to GPS DD object. In this case, essentially, all objects are now GPS DD object. Because what's GPS? GPS DD is the ancestor of both.
so you said they're the. Okay, I'm pretty sure you explained this, but
Sure, no problem.
what if we have a labeled GPS object?
Right,
It's a bottom class, it's a child class of GPS DD.
right.
Why would we want to shift up? Why would we want to shift that object up to GPS DB if it's already technically a part of it?
I need to do that is because I want to, for example, I want to have a storage. I want to have a way to treat all the object with a unified abstraction. So I used an example yesterday when I'm moving.
I just thought of that, but I think the part that I'm missing is if it's already a label, if it's a labeled GPS object, can't we still treat it as a GPS DD object? Because
Yes.
it's technically a part of it. So
Right.
why?
It is usually is because I want to store it somewhere
Oh,
else.
okay.
I want to store it in a vector or store in a map.
So we want them all to be in principle, it's the same, but we want them on paper to have the exact same objects. We can put them all in the same place. So like
Right,
they're all in
right,
one box,
Right,
like
right.
in your example. Okay.
Exactly. Yeah, that's usually typically the most common way for this to occur is that I don't want to deal with like a 30 different type.
Yeah.
I want to convert them to one type and store there in the array. Because if you think about an array or vector, they're just basically a array of the object that belong to the same type.
So if we have like a labeled GPS, so two parts. So first that happens, we want to do that mostly because of memory. There's no real like other reason why we want to do this other than just practically storing them, like in practice. Is it because like
yes, in the programming, it's not just storing them, but in programming, sometimes we want to apply a function to all this, say 5 million object.
Yeah.
Okay, assuming this 5 million object belong to originally when they created belong to 30 different class. Okay, 30 different class. So if I want to write a loop, say for I is equal to 0 to 30 million. Okay, 3 million, whatever. And each of the iteration, I need to handle one object, right? And I want to apply a function, say dump to JSON for that function. So if you imagine the code, if those 3 million objects, they belong to different class, then syntactically, how you will be able to write that code, the syntax, correct.
I think this is the part that I'm tripping up on because you said, so all those 30 million are a child class of the class right above it, right?
Right.
So if we were just to put that into like the for loop into the top class, wouldn't
Right.
that apply to all the child classes anyways without us having to upcast?
Yes, that's true. But you must store it somewhere, right? You must have the reference or whatever the pointer, you must store somewhere so you can let your for loop to go through each one of them and treat them uniformly. Because, right,
Going off of that, then what in the child class? Because the child class has a copy of all the parent class components, correct?
right.
But then you were mentioning also that when it's printing out information, does it get the components from the parent class, even though it's its own copy?
It's already have it. So if I have a parent at the time when I do object creation, when I create the object, I already have a component.
Yeah, so it's the part, you have a whiteboard?
Sure. Can we use a PowerPoint to draw it? Because we have a slide. I can try to, you can use my screen to do that. Let me try to dig it out. It's probably easier for use the. So I have this, I showed this yesterday. Let me see this. Can you move over here, Jonathan?
Yeah.
Wait a minute, I lost the slides. Oh, here. So I already have things looks like this, right? So what do you want to draw?
So I was gonna like put, so we have the top class, which is the parent class. And
Okay.
we have, let's say, the 30 million children.
No, that
Or
not
the- sorry.
30 million, only 30
Let's say
children.
let's say we have 5 children.
Okay,
So if we were to put a for loop into the parent class
right,
that iterates through all of its objects,
right,
because the objects in the child classes
right,
are all objects of the original parent class,
right,
the for loop would apply to them anyway, right? Without us having to upcast.
right.
And there would also be a pointer to them because technically they're objects.
Right.
So what's the point of like making them of upcast? Like that's the part I don't understand.
No, before you can apply the for loop,
Mhm.
you have to upcast.
Is it just is it like
You have to, let me show you why. Okay, I think I start to understand your question, but I want to just try to write the code because it's related to how you can even write the correct program by applying multiple different class type over here. Okay, so let's assuming I have this GPS and GPS DD. Let's try to compile. Let's try to write the program in test this one. Okay, so I'm going to create. Let me create another object called. Okay, I'm going to create another 3 object. I call it GPS GPS1. I don't need this. Let me create another called GPS2, GPS3, right?
Mhm.
Okay, so in order for me to have a loop, I need to use some kind of array, or I use what I call a vector. So in this case, I'm using vector std vector. The type is going to be, let's do this, GPS dd star. Okay, so each of the element is a pointer to a GPS object.
Yeah.
Okay, and this vector, I call it GPS vector.
So that vector will just have all the stuff in GPSC. So it'll be like 1, 2, and 3.
I haven't put it in. I
But
have to
if you
put it in.
Okay.
I have to put it in, right?
Yeah.
So I think it's going to be append. Okay, so I'm going to call GPS vector append. And I believe when I append, I will just say and GPS home Woodland. Okay, I'm actually adding the first object into this, and then I'm going to append the second object, which is a GPS TLC UC Davis.
So these are part of the labeled GPS, right? So this is part of the
Yeah,
chapter.
I'm going to put all of them.
But these two specifically, just to make sure.
Right. This
Yeah, okay.
three are this three are labeled GPS,
Which is
but because the vector was defined as a GPS DD,
Mhm.
this is automatically upcast.
Oh,
It's already being upcast when you try to store
so
it.
we don't have to manually upcast it when
Right,
we try to work
right.
with it as a GPS DD
Right. It
object,
will
it'll
automatically
auto-
upcast for
Oh,
you.
well, then that makes sense.
Right.
Okay.
Right.
Because
But
I was okay.
Yeah,
Yeah. Then that
yeah.
makes
right. So that's why when you go through the loop, the program will see everything you take out from the vector is a GPS DD
so
pointer.
it'll automatically up. Like we don't have to
Yeah.
go and upcast all the classes. Like
Right.
put code into it to upcast it because when you actually do the for loop itself, it'll
Right.
upcast automatic. Oh,
Right. Under this case, you don't need to do that. But under some other case, sometimes you have to be explicit.
mhm.
But this case, let's try to see if this compiler will work. Okay, because I want to see whether compiler will complain because sometimes I could miss something. And GPS 1. Let me try to do this. Let me see if the compiler is happy or not happy. I don't know. Okay, sure, you're welcome. Maybe. Okay, now it has arrow. Okay, vector is not is that push? Not append, probably push. No, sorry about that. I know it's something I'm rusty. It's probably push. Let me see if this is push is okay. E pushes now. Wait a minute. What is a vector? What is a vector? Sorry about that. Sorry, STT vector. Okay, I'm going here. The function. So I have to look at this. Pushback. Sorry, it's pushback, not push. So it's pushback. 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 Okay, so now it works. So with
Mhm.
that pushback, so it will but if you look at the vector itself, the vector GPS vector is going to be from their perspective when you retrieve, all of them is a GPS DD object.
Mhm.
Yeah. So therefore, if it's not virtual function, we are essentially lost the original data type when those
Mhm.
objects were created.
And
Yeah.
then, so okay, I think back when we had pointers, I got it, but like not 100%. So using pointers is a little confusing still, especially when we like combine it with other things.
Mhm.
So when we have SD vector, you put GPS DD star, that means you're referencing it to anything that's GPS or placed in the memory with the GPS DD objects.
It's essentially, in this case, vector is an array.
Yeah.
So this is essentially array of something, right? So this case is array of pointer. So every single element in the array is a pointer.
Okay, and then this is like, so, and then GPS home woodland is also a pointer, so we're dereferencing it?
It's just an address. It's just a pointer. This is a pointer because why? Because every single thing in the GPS vector is a pointer.
Mm-hmm.
So therefore, I'm inserting a pointer
Mm-hmm.
to one of the element in the vector. So I'm actually adding a new pointer to the array.
Mm-hmm.
Think about vector is just an array.
Yeah.
So let me try a different thing. I think I can do this as well. Let me try to see if I do. What can I do with this? I'm a little bit rusty on this, but let me try. It might work, it might not work. So I make a reference. It's a vector of reference, not vector of the original object, not reference of, it's just a reference. So over here, I think I can just directly do this. Let me get rid of a 3 and the other 3. I didn't change. Let's see what happened. Okay. Okay, so I have some arrow, but what was the arrow? Is that because oh, it's a lot of arrow message. Okay, here, over here. Yeah, using reference as an array sometimes will causing the problem, just like what I'm doing here. Try to see what's the original, what's the source of the issue.
Maybe a little higher. Right here. Is it this one?
I see this line earlier as well. There is an earlier line. Let me try to think about what was the arrow I have. Okay, but I will figure that out. But I know that this part, if I declare a vector of, yeah, I think if I do this, I know it works. It's very safe when I use a pointer, but using reference is always, I have certain spot that I have to check the, I think there is a way I can make it to work, but there is a syntactically, I think I need to work out
Okay.
to do that. But this way is just, GPS DD star is just like the way we use a reference, but somehow the compiler do different tricks on that one.
Okay. Got it. Thank you.
Okay, you're welcome. Okay, I'm going to stop recording.